Good day once again. It's Ishola Adedeji. All right, once again, you welcome to Success Enlightenment. All right, if you've been coming across this channel, but you are yet to subscribe to this YouTube channel, all right, make today your day. Just subscribe to our YouTube channel as you keep on getting entertained and getting more of the juicy part of education enlightenment, especially economics. And if you are a student, an undergraduate student, BSc, undergraduate student, economics, all right, this is a YouTube channel that it is a must you have on your what? On your YouTube. You just have to subscribe to this channel because there are a lot of quality content right here that can actually help you achieve your academic goals and success. All right. With that being said, all right, let's get right to the business of which is what? What is probability distribution? What is a probability distribution? All right. Now, many times, all right, when you hear the words of probability distribution, students almost find it confusing. Like students almost find it confusing to actually get exactly what we are talking about, right? But simply a probability distribution is a table, graph, or a mathematical function that describes the likelihood or probability of the different outcome of a random variable s. All right, what are we saying? All right, uh, what's a random variable first? A random variable is is any variable whose value is determined through a what? Through a random experiment, right? Any variable whose value is ascertained through a random experiment is a random variable. All right, with that being said, all right, now a probability distribution is, it could be a table, it could be a graph, it could be an equation, it could be a formula, it could be a function. All right, but what is important is that a probability distribution shows the outcome, that is the possible outcome of a what? Of a random what? Experiment, and the likelihood of each of these outcome occurring. All right, it shows the possible outcome of a random experiment and the likelihood of each of these outcome occurring. When you hear likelihood, is same thing as what? Probability. All right, same thing as probability. All right, so um to go further with our discussion on probability distribution, we have to check out this very problem to illustrate what we mean by what? A probability distribution. Like this question is asking us to form a probability distribution table and graph from the likelihood of the occurrence of heads from the flipping of a coin three times. Now, from here, our random experiment here is the flipping of coin three times. We are to conduct an experiment of flipping a coin three times, and our random our occurrence here, which is the random variable x, is the number of heads. Our random variable x there is the number of heads we are going to get from the random experiment of flipping a coin three times. All right. Without much wait, let's get straight and solve this question. And we are going to present the experiment. We are going to find the probability of the outcome, and from there we are going to form our probability distribution table. And from the table, we are going to form our probability distribution graph. Sorry. Let's get right into having a task here of conducting a random experiment. Right. The nature of a random experiment is the flipping of a coin three times, right? We are flipping a coin three times. So the first thing we are going to do is to actually conduct the experiments, right? Is to conduct the experiment, which is the flipping of the coin three times. Okay, the flipping of the coin three times. Now, if you flip a coin for the very first time, let's say we have the first flipping of the coin. Right, there are two possible outcomes, which is you can have an head and we have a tail. All right, you can have a head and a tail. Now, if you choose to flip two coins, so the second time you're going to have also an head, a tail, and head, a tail. All right, for the third time, we can have an head, a tail, an head, a tail, an head, a tail, and head, a tail. All right. Now, if you list all these possible flipping, now you see you can The three coins, all of them can come out in head. You can have an head, right? You can have an head, tail. That is two of the coin coming out in an head, the last one coming out as a tail. You can have a what? An head, tail, head. You can have an head, tail, tail. Alright. You can have a tail, head, head. You can have a tail, head. You can have a tail, head, tail. Then you can have a tail, head. You can have a tail, tail. Right? These are all the possible outcome you can have from the flipping of the coin three times. All right, when you count them, we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So which means total possible outcome we can have is what? Is 8. All right. Now when you look at all of them, each of them, the possibility of you having 8 head will be what? Be 1/8. This probability will be 1/8, 1/8, 1/8, 1/8, because the total possible outcome is what? Is 8. All right. Going further in this scenario, why we need to actually conduct the experiment first is we're having a random variable which is number of heads. So now you have to ascertain how many possible head can you have. From here you can see that it's possible you have no head at all. You can have a zero head. So also you can have just one head, alright? You can have two heads, you can have three heads, but you cannot have more than three. So which means the possible outcome we are dealing with here, we are focusing here now is what? Is zero, one, two, and three. Is zero, one, two, and three. So now our focus now, since now we have our possible outcome, our focus now is what? Is now to conduct a probability distribution table from these possible outcome. So that's will be our focus now, to conduct a probability distribution table from this outcome. Probability distribution table, you have to label it probability distribution table. Our probability distribution table. All right. So let's start by the possible outcome that we can have. All right. The possible outcome that we can have, we have y. Let's use y, which is what? Let's say number of what? Head. Number of heads, then probability of what? Y. Alright. Usually the capital letter are usually used to denote the word, the random word variable, while the probability is usually denoted in what? In small letter. So that's why our y here is in capital letter and our probability is in what? Small letter. So we can have a zero head, we can have one head, we can have two head, and we can have what? Three head. Okay? We can have zero head, we can have one head, we can have two head, and we can have what? Three head. Okay? Can have three head. Now, the only outcome from our random experiment where we have a zero head is where we have T, right? That's the only outcome where we have what? Is zero head. And total possible outcome there is 8. And this is just one. So, probability of having a zero head will therefore be what? Will be 1/8. So, probability of this will be what? Will be 1 over. Probability of having zero head will be what? Will be 1/8. We have this as 1/8. That will be 1/8. Also, the probability of having, what's the probability of having one head? Now, from our experiment, this scenario where we have only one head, we have tail, head, tail. That's only one head. We have tail, head, tail. We have tail, tail, head. We have tail, tail, head. We have tail, tail, head having only one head. We have head, tail, tail. We have tail, we have head, tail, tail, head, tail, tail. We have three possible outcome where we have only one head. Only one. Let's check out. Okay, we have tail, tail, head. We have tail, tail, tail. Sorry. Where we have one outcome, we have one head. We have head, tail, tail. we have tail head tail, we have tail tail head. Alright, we have tail. This one there's only three possible outcome where we have only one head. So therefore the probability of having one head will therefore be what? 3 all over 8. Will be 3 all over 8. Probability of having only one head will be 3 all over 8. Okay, 3 all over 8. So we have 3 over 8. This is probability of having what? One head. Now what's probability of having what? Two heads. Alright, probability of having two heads. Alright, the scenario where we have two heads, we have what we call heads. We have heads, head, tail. We have heads, tail, head. We have tail, head, head. We have tail, head, head. We have head, head, tail. We have head, tail, head. We have tail, head, head. So there's also three possible outcome where we have what? Two heads. So therefore the probability of having two heads will therefore be what? 3 all over 8. It will be 3 all over 8. It will be 3 all over 8. It will be 3 all over 8. Okay? It will be 3 all over 8. Now, what's the probability of having three heads? Now, probability of having three heads, the only place where we have three heads from our random experiments where we have head, head, head. So therefore, the probability of having three heads will be 1 over 8. Be 1 over 8. So that will be the probability of having three heads. That will be 1 over 8. Alright. So this table is our probability distribution table. Alright. This is our probability distribution table. Right, we can draw this table more neatly. We can draw this table more neatly. Let's draw this table more neatly, and let's put this 1 over 8, 3 over 8, 3 over 8, and 1 over 8 in what? In decimal point. But what we must note here, should in case you have to do something like this in an exam situation, what you must know that the sum of all your probability must always be equals to 1. That is, if you have 1 over 8, we have one. If you add 1 over 8 to 3 over 8 to 3 over 8, if you add it again to 1 over 8, all this will give you what? 8 over 8, which is equals to 1. So total of the probability we have to be equals to what? 1. Alright, so let's draw this our prioritization table. Let's draw this. To draw this more neatly, this is what we have. Alright, uh we label it again. That's our y. Let's label our y. Our y should be number of heads, number of heads. Then our small letter y, that's probability. Probability small letter y. Alright, that's not neatly written. Let's have this like this. Okay, let me change the color. Let's use the red. So we have this probability of what? Small letter y. Alright, so is 0. So probability of having 0, that's 1 over 8, 0 8, and that will be what? Is 0.125. Alright, if you multiply this by 100, it means that there's a 12.5% chances of having a zero head in the flipping of a coin three times. You can approximate this to 13%. Alright, 13% chance. Okay, so what about when we situation where we have one head? Alright, that would be what? 3 all over 8. That would be 3 over 8. And 3 all over 8 in decimal, what does that give us? That will be 3 divided by 8. That will be 0.375. This is what? Is 0.375. Alright? That will be 0.375. Alright, this implies that the probability of having what? A one head is what? It is 0.375, which you can also approximate to be to is 37.5 what? Percentage. Alright? Now the probability of having two heads is that will be what? 3 all over 8. That's 3 over 8, which is also the same thing as what? 0.375. And probability of having 3 heads, that's what? That will be 1 over 8. And that will be what? Is 0.125. That will be 0.125. Okay. Now, should in case, let's say you are asked, examiners questions sometimes, you really don't know what they are going to say. So they ask what probability of having 4 heads from the flipping of a dice 3 times. So the probability will be what? Is zero, right? Is zero because of in our random experiment, there was never a time where we have what? 4 heads. The highest number of heads we had was what? Was 3. All right. Now with this table that we have formed now, we can now this is a probability distribution what? Table. It shows the likelihood of the occurrence of the what? Of head in a random what? Experiment. Right? It show the likelihood of the occurrence of it, and it show the number of outcome, which is the x, which is the y, and the probability of it occurring. Right? It shows the outcome of head. You can have 0 head, you can have 1 head, you can have 2 head, you can have 3 head, you can have 4 head, and it shows the what? The probability, which is either the probability of having a 0 head is 1 over 8 or 12.5%. Probability of having 1 head is 3 over 8 or is 0.375%. Probability of having 2 head is 3 over 8 or 0.375%. Probability of having 4 head is one is what? Is 0. Right? So with this table now we can form a probability distribution graph. Right? We already have our probability distribution table. Now from our probability distribution table, we want to draw our probability distribution graph. All right? Now makes let's use the y-axis. The y-axis stands for probability. Let's y stands for probability, and let this x-axis stands for the outcome. Right? If you use a scale of 0.1 to a scale of 0.1 for the y-axis, we have this is what? 0.1. This will be 0.2. This will be 0.3. This will be 0.4. All right, and this here we have here is 0, 1. Sorry about that. Let's write our one very clear. Let this be 1, this 2, this 3, then this 4. Right? Now, what's the probability of having a 0 head? That's be 0.125. So you can trace that here. You can trace that here. It is 0, 1, 1. What probability of having 1 head? That will be 0.375. You can trace that to the top. 0.375. That's close to 4. Okay. What's the probability of having 2 head? That's also 0.375. Trace it to the top. What's the probability of having three head? That is 0.125. Probability of having four head obviously will be zero. So now, if you join all these points together, this graph we form here is a what? Is a what? Probability distribution. It's a probability distribution table. It's a probability distribution graph rather. This is the probability of y. It is a random variable. Is denoted by small letter y, and it is depicted in this table. And this completes what we are asked to find. This completes what we are asked to find. We are asked to find the probability distribution table and to find the probability distribution graph. All right. In the first example we deal with, we've been able to show clearly the probability distribution table and probability distribution graph from decision of tossing a coin three times. All right. Now we're having another task here. Is another question here we are to deal with. All right. This question is asking us what will be the probability what is the probability distribution of a random variable x, which is the sum of two roll dice? All right. This also we have an experiment here. The experiment here is to roll a dice twice, and the outcome we are interested in is such that we are dealing with the sum of the what of the possible outcome of rolling a die. All right. Succinctly and very precise, without taking much of our time, we are going to solve this question now. And at the end of this, I believe any student out there who have taken their time to watch this video can present probability distribution table and graph of any form, irrespective of how the question is being structured. Right, let's get right into it. So we have a situation of tossing a die twice. All right. So what you simply do first is you go ahead and we form our probability distribution table. All right, if you are tossing the die, so you have the possible outcome you can have there. You can have a one, you can have a two, you can have a three, you can have a four, you can have a five, you can have a six. All right. Now in this scenario, we are tossing what? Two dice. So you are tossing two dice. So let's put the second die on our. We are having one. Okay, we are having one here. We can have a two. We can have a three here. Oh, sorry. Can have a one. Alright. You can have a two. Can have a three. You can have a four. can have a 5, and you can have a 6. This table is our table of our random experiment of tossing a dice twice. Alright. Now the first possible outcome here, we can have a 1-1, can have a 1-1 situation, we can have a 1-1, that is the first die 1, the second one 1. um You can have a 1-2, you can have a 1-2, you can have 1 and 3, you can have 1 and 4, you can have 1 and 5, you can have 1 and 6, you can have 2 and 1, you can have 2 and 2, you can have 2 and 3, you can have 2 and 4, you can have 2 and 5, and you can have 2 and 6. You can have 3 and 1, you can have 3 and 2, you can have 3 and 3, you can have 3 and 4, you can have 3 and 5, you can have 3 and 6. You can have 4 and 1, you can have 4 and 2, you can have 4 and 3, you can have 4 and 4, you can have 4 and 5, and you can have 4 and 6. You can have 5 and 1, you can have 5 and 2, you can have 5 and 3, you can have 5 and 4, you can have 5 and 5, you can have 5 and 6, you can have 6-1, you can have 6-2, you can have 6-3, you can have 6-4, you can have 6-5, and we can have 6-6. Alright, these are all the possible outcomes. And when you count them all, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. See that total possible outcome we can see here is what is 36. And by this it means all of the outcome each individually has a probability of what? Of 1 over 36. Now what you are interested in is the probability of having a sum. Probability of having a sum from here. You check what are the possible sum we can have, alright? In this particular occurrence, definitely let's use y to be our probability, alright? Y, but let's use s since we use y the other time. Let's use x. So capital letter S, alright? That will be sum. Then here we have the probability of x. Right, the possible sum we can have here is this. We can have 1 and 1, that will give us 2. We can have a 2, we can have a 3, we can have a 4, we can have a 5, we can have a 6, we can have a 7, we can have a 8, we can have a 9, we can have a 10, we can have an 11, and we can have a 12. Okay? The greatest possible sum we can have, since is a function of, since we are dealing with a diet, the greatest possible sum we can have is 12. Is 12. Okay? That's the highest possible that we can have is 12. Is 12. Alright, so from here now we have to check how many likelihood of 2 can we have here if you add everything together. Now the first one here we have 1 and 1. We have 1 and 1. We have if you look at everything we have there, only 1 and 1. Only 1 and 1 gives 2. Only 1 and 1 gives 2. Only 1 and 1 gives 2. So therefore, we can say categorically that the probability of having a sum that is a 2 it be what? It be 1 over 36. That's for the first outcome. Alright, that's one over. Now for the second outcome, we have a sum like two. The dice produce two figure that when you add it, the two numbers together, it give us what? 3. So let's check the table. Let's check the table again. Which and which can we add together? Will give us what? 3. All right. We have one plus 2 will give us 3. 1 plus 2 will give us 3. 1 plus 2 will give us 3. This will give us 3. This will give 3. 2 plus 1 will give us 3. So we have only two of them that will give us 3. We have 1 plus 2 and 2 plus 1. So we have only 1 plus 2 and 2 plus 1 that can give us 3. So therefore what we have here is what? Is 2 all over 36. 2 over 36. Okay? Now next thing we have is what? Is 4, right? Sum of 4. Let's see which and which we sum up together will give us what? Will give us 4. Okay? Which and which when sum up together give us 4. 1 and 3 will give us 4. 2 and 2 give us 4. 3 and 1 give us 4. So we only have 3. Alright? We only have 3. And by application, The probability is therefore 3 over 36. You have 3 all over 36. Okay, that's for 4. Now we have to check for 5, that some of them give us 5. All right, some of them give us 5. 1 and 4 gives 5. 2 and 3 is 5. 3 and 2 is 5. 4 and 1 is 5. So we have how many outcome? We have 4 outcome. We have 4 outcome. And by implication, their probability will be what? Will be 4 over 36. That will be 4 all over 36. That's 4 over 36. Okay. Now 6. How many of the sum give what? 6. Now we have 1 and 5 give 6. 2 and 4 give 6. 3 and 3 give 6. 4 and 2 give 6. 5 and 1 give 6. So when we add all of them together, we have 1, 2, 3, 4, 5. So which means the probability there will be what? It will be 5 over 36. Probability will be 5 over 36. That's 5 over 36. Okay? 5 over 36. Now how many of them gives 7? Alright? 1 and 6 produce 7. 2 and 5 produces 7. 3 and 4 gives 7. 4 and 3 gives 7. 5 and 2 gives 7. 6 and 1 gives 7. So we check them, we have what? 6. 6. So that means their probability is going to be 1 or 6 over 36. The probability will be 6 over 36. We have 6 over 36. We have 6 over 36. Now we want to check for the probability that will give us what? 8. That their sum will be what? Will be 8. Alright? Their sum will be 8. The first one we have here is 2 and 6. That's 8. 3 and 5. That's 8. 4 and 4. That's 8. 5 and 3. That's 8. 6 and 2. That's 8. So we have 1, 2, 3, 4, 5. So we have 5 of them, that their addition gives what? 8. So mean the probability of 8, we're having a sum of 8 to be what? To be 5 over 36. Alright. Now the probability that their sums is equals to 9. Probability that their sum is equals to 9. Okay. Probability of their sum equals to 9. So here we have sum of those whose probability is equals to 9. We have 3 and 6, that's equals to 9. 4 and 5, that's equals to 9. 5 and 4, that's equals to 9. 6 and 3, that's equals to 9. So we have 4. We have 4. We have 4. That will be what? 4 over 36. That will be 4 over 36. Now, probability of their sum is equals to 10. Do the same thing to that. 10. Probability of having their sum equals to 10. Alright? Probability of having their sum equals to 10. So where do we have 10? Alright. We have 4 and 6 to be 10. 5 and 5 to be 10. 6 and 4 to be 10. So total possible here we have 3. We have 3. So the probability of having the sum of 10 is what? 3 over 36. That will be 3 over 36. So the probability of having 11, having a sum that is equals to 11, That will be, let's check what and what gives 11 here. So we have 5 and 6 is 11, 6 and 5 is 11. All right, 7 is 11. So we have just 2. You have just 2. You have just 2 that is sort into 11. So that will be 2 over 36. And finally, probability that we have it, that their sum is equals to 12. Their sum is equals to 12. This is supposed to be 6 and 6. Alright, we have only one there. Therefore, the probability is therefore 1 over 36. That's 1 over 36. Now, the table we form thus is a probability distribution table. Table we form is a probability distribution table. Table we form is a probability distribution table. Now, you can go further by putting it all in decimal. All that is important is what? Is when you add everything together from 2 to 12, that is 1 over 36 plus 2 over 36 plus 3 over 36 plus 4 over 36 plus 5 over 36 plus 6 over 36 plus 5 over 36 plus 4 over 36 plus 3 over 36 plus 2 over 36 and plus 1 over 36. The total will give us what? Will give us 1. Alright. This is a probability distribution table of tossing, flipping a dice twice. So now, we summarize what you have gotten. You can summarize what you have gotten easily. You can have parameter x, which is what? The sum we are interested in, which is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. I can have the probability of x, which is p small letter x, to be this will be this 1 over 36, this 2 over 36, this 3 over 36 as calculated earlier, this 4 over 36, this 5 over 36, or this 6 over 36, this 5 over 36, this 4 over 36, this 3 over 36, this is 2 over 36, and this is 1 over 36. Okay. All right, you can present this probability that you have found here. You can present them all in decimal so that you can form your probability graph easily. You can present them all in decimal. Okay. Yeah, through that, it's not that hard, right? Just go to your press your calculator. What is 1 over 36? That will be 0 point. This will be is 0.0. The space doesn't want to contain it. Space doesn't want to contain it. Alright, this will be what? Uh, This will be 0.027. Alright, the space still don't want to. Okay, let's write it slantly because of the space. This will be 0.028. Okay, that will be 0.028 approximately. So now what is probably what is 2 divided by 36? That will be 0.056. What is 3 over 36? That's 0.083 approximately. What is 4 divided by 36? That's 0.111. Write the one way. Okay. What is 5 divided by 36? 5 divided by 36. That's is 0.13. Okay. Not 1 4. You are doing 3 into 3 decimal places. Okay. That will be 0.139. What is 6 divided by 36? That will be 0.167. 7.167. 5 divided by 36, that's 0.139. 4 divided by 36 is 0.111. 3 divided by 36 is 0.083. 2 divided by 36 is 0.056. And 1 divided by 36, that is 0.028. Alright? You can even go further by expressing this in what? In percentage. You can go further by showing this in percentage. Alright? And going further by showing this in percentage. This will be 2.8%. This will be 2.8%. Percent. This will be 5.6%. This will be 8.3%. This will be 11.1%. This will be 13.9%. This will be 16.7%. This will be 13.9%. This will be 11.1%. This will be 8.3%. And this will be 2.8%. To be 2.8%. All right. Now, what you have here, you can now take this and draw this word graphically. You can present your work product distribution graph with this information that now our task now is to present what we have already found in the probability distribution graph. All right. Let's use the exact probability that we find. Let's have this. All right. Let this be 1 over 36. This 2 over 36. This 3 over 36. This 4 over 36. This 5 over 36. And this 6 over 36. Over 36. And here be what? 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11, 12. This size, this S axis represent outcomes, and here stand represent what? Probability. Represent probability. So now, from here, what do we do from here? So you just have to plot what we have here. Now, probability of having a sum of two is what? 1/36. 1/36. But having a sum of three is what? 2/36. But having a sum of four is what? Is 3/36. Sum of five is what? 4/36. Now, probability of having a sum of six, that's 5/36. But having a sum of seven, that's 6/36. Probability of having sum of 8, that's 5/36. Sum of 9, that's 4/36. 10, that's 3/36. 11, that's 2/36. And 12, that's 1/36. When you join all these points together, what you have is the what? Is a probability distribution graph. We often we join it together the probability distribution graph. Probability x equals to, this is the what? Our probability distribution graph. And by this we come to the end of this. With that, we come to the end of our discussion today on probability distribution. I remember my humble self, Mr. Ishola Dedeji Michael. All right, feel free to engage me. My contact is attached to every single of my video. All right, if I explain a thing and you didn't get it, feel free to contact me. I'll be more than happy to actually discuss it again and again with you guys. And if you have any problem you're trying to tackle with probability distribution, take it as an hobby to first find the probability as it is, and don't just put it in table. Draw your probability distribution graph. It actually adds more value to your answer. All right. If this is your first time coming to my channel, or you've been coming but you've not subscribed, please subscribe to my YouTube channel and get me engaged. I celebrate and appreciate every thumbs up and every comment, either positive or negative. Yeah, thank you once again. Till next we meet. Probability distribution. Ishola Adedeji Michael. Success enlightenment. Thank you.